TechRabbit here. So now it's time to continue the series on Rust, and this time we're going to handle Rust crates and modules. And this section is quite a heavy one, so I suggest you pause the video, get a cup of coffee or tea or some other beverage you like, and sit back and try and absorb the information. Anyway, let's get started. So, what are Rust crates? Well, Rust crate is a concept you use to package up your software module that you've created into a package that then you can manage and ultimately publish to the public register, which in this case is crates.io. So this is a service where you can actually upload your software. And there are already, as you see, 181,000 crates with, I don't even know if this is millions. Is that billions then? 131 billion downloads. Yeah, as you see. But I mean, that's the idea. So you create ultimately you create your software source code in Rust in a crate, and then the objective is to progress towards its ultimate publishing on Crates.io if it isn't something that's used just for internal use. And this has actually quite a good search utility, so you can actually find things. And I'm going to use a very simple example here. I'm going to use the image crate, which is a publicly available crate. And as you see here, we of course it finds everything to do with the image, but the main objective to look at is this one. And then you can see all-time downloads and recent downloads and was it updated. And so that's actually quite a good thing to have as basic information when you're checking out the status of a crate. And then they also include, very useful here, is while you're in Crates.io and then you just search for a crate, you find it. Then and this could be for any dependency that you happen to add to your project also. But then you can actually easily get access to the home page. So it will take you to wherever it is hosted, and usually this ends up on a GitHub page. And then you actually get access to the raw source code, the unpublished code. And then it has a link to the documentation, if anything, if it has been created. And this is actually published to a docs.rs site. So we'll come back to that later in the presentation. And then you have access to the repository, and often there can be a split between the home page and the repository, or the repository is the home page, so it depends on the project setup. And then once you've located the crate and you know the version that's available, then you can actually come back to your project into the cargo terminal, and then you can add it as a dependency. So here we have the image crate added with the specific version it should pick up. And we'll be coming back to this in more detail a little bit later. When you're dealing with crates and stuff, it's actually sometimes useful to actually run the build process with the bareboss setting configured, because then you can actually get more information what's going on in the background. So as we see here, it'll show all the command lines for building the different dependency crates and then ultimately your own code. I'm not suggesting that this would be an everyday activity, but sometimes for diagnostics it can be useful, especially when you happen to download a crate that actually crashes and doesn't compile correctly. It can happen from time to time. But as you see, it's lots of different options here. And everything is of course explained in the documentation, and in my experience isn't that many times one needs to, for example, go in and analyze /the embed bitcode node and find out specifically why that option is being used. Yeah, don't really have to be. At least in my experience, one doesn't have to be worried about that. But one needs to know every single option used. But it's useful to have the variables option so that you can actually dig into the details and find out what's going on in the background. So there's only a few options that I'd like to actually highlight. Well, one is this cargo build crate type lib, so that creates a library. And, but this is handled automatically by Rust. So for example, in this case in the project we have calc separate lib and then we have lib.rs. So the Rust system, compile system, build system recognizes this as a library and then compiles it as a library. So you don't need to manually use that switch, but it's interesting if you're looking at the variables, then you can see, okay, which of them are being created, which of the packages are being created as libraries. And then there's another option, which is called extern. And then you can have a whole bunch of names. And this might be of interest if you're looking at the variables output, just to find out that, okay, when the module is being compiled, what external modules or crates is it referring to when it's compiled. And then we have the opposite from the library, which is crate type, and then it's bin, so then it creates an executable. But as this is also derived automatically in the build system, so it will recognize that, okay, this chunk of code, or, the code that contains main, should be compiled as the target executable. So it's also nothing you need to manually set. So I thought I'd throw in a word about build profiles and that you can have in the cargo terminal file. And there are many options you can throw in here, but I'm trying to keep to the real basics, what you would usually expect. So, and to document this. So if you run cargo build, then it will be using this so-called dev profile. And then under the dev profile, you can add different options as needed. I mean, in normal programming that I kind of do on an everyday, on a more general basis, there's very seldom one needs these profiles, at least in my experience, but they are there. So, there's a profile option for cargo build, and then there's another one which is called cargo build and release. So, and I'll give a brief description of the release profile a little bit later. But the most important option, which is usually seen used, is that you actually say that debug is true. So you prevent the release option from removing the debug information. And then there's the profile. You can have an independent profile for the testing. And what did I have about the release option? This is actually interesting. Lots of, especially if you're beginning with Rust, you don't actually realize that this exists at all, because you just use cargo build as is, and you never go to the extent of saying cargo build release. But when you activate the release option, then that's when it actually optimizes the binary code, and it will then strip the debug symbols. So basically, you have a target executable or binary that's not debuggable as such. And then it also, which is actually very important, is that when you use this / release, it will actually remove runtime checks that are only present in the debug builds. So you could have a situation where you could have a hard panic crash in the released binary, and then you won't really know what's up. It's kind of good and bad, but well, that's what happens. So you don't have the full extent of runtime checking when you use the / release option. So if you would I have mixed feelings of this, that it takes away the run on those checks. But anyway, that's what it does. So we had a little bit of a look at the concept of crates, publishing crates, and how to pick up one crate and define it, and then a few words about build options and build profiles. And now we need to get into the nitty-gritty details. So let's get started and have a look at modules. And the first example we'll look at is local modules. And we have something called calc local, so let's have a look at that. So here we have a module called calc local, and I tried to keep these examples really simple. And then in this module we have some public functions, and then we have a function that will in its turn use an internal module. So you have another module embedded inside the first module, and this module has both a public function and a private function. And then a few things that one should note. So in this case, you can't, from this module level, you can't call the private member of the submodule. And then from the submodule, you cannot use the functionality defined in the higher module, not by default. I think there is actually a way where you can hack this, but I actually don't recommend it. It makes the code a little bit loopy, in my opinion, so I think that one should try and avoid that. And here we can see that it's using the module. So this one, of course, that's a very simple one. That'll work. And then subtract will also work because they're public. But then you can't go and use the internal modules functionality because it's not publicly re-exported. And then you can't access the multiply functionality because it's not public. And then this is a special function that to be able to use the subtract functionality in the internal module. So if you want to see the error message you get, then you just uncomment the lines and you can compile it and see what happened. So I tried to make it a simple example of what accesses are possible and what are not, at least for the top level cases. And then I made it pretty much exactly the same example, but now I'm demonstrating that you could actually have this functionality in a separate file. So here, if we look at this file, it's the same content, and then you just give it the name, calculate separate, and then it's treated as its own module. And then you can just refer to it like this. And so it's the same access regulations that apply, the same access rules, which makes it convenient in my opinion. So then you can actually have the module code either embedded in the same code base that you're working on, or you can move it into a separate file, have it reside there in parallel with the rest of the code. And then you could also put the module definition into its own separate subdirectory. And then the trick here is that then you have a file called mod. You create a subdirectory and then you have mod.rs, which is kind of the root object of the module. And then you re-export the functionality you want to make available on a higher level. And then the idea behind this is that I put the add here and then I put the subtract here in the two separate files. And then I added also a usage of a constant to indicate how you refer to the parent. So you use the super keyword to refer to the top level. So here we have the constant on the top level level of the definition for the module in question. And then you can refer to that by using the super keyword. And then the usage is basically it's the same. So you have access to the add and access to the subtract. But then of course when you have it in a separate directory, my idea was that you wouldn't just have like one function per file. The idea is that you would make a whole group of like different types of add routines and different types of subtract routines or any other functionality you have, and then you can expand on that. So you can take that. You could take this example, and then you could, of course, build it out to be a real module with a whole pile of functionality, not just the add and subtract. But using this, you have the template, so this is a good starting point to actually expand it and use it yourself. And then you can also use this code base to test and validate, get a feeling of how it works before you actually commit to. So when it comes to modules, as demonstrated, you can have a module in the same code base. You could move it into a separate file, or if the modular functionality gets too much, you can move it into a subdirectory, which means that then in turn you can break that module into separate files. So it depends on what you're programming and what your logic is. Then you have the flexibility of all three levels of options for modules. So let's have a little bit of a look at module internal structure referencing. So you can use an absolute path, and that starts with this double column addressing. So that this is indicative of that it's the root. So you start from the top, and then you go into the standard library, and then into the F64 functionality, and then into constants, and you finally access pi. And then the use option, what would be recommended in this specific case is you bring it down to this level, to the const level. And then you say std F64 const. As you notice, it doesn't actually define the root because the default starting point is considered, the default reference is considered to be the root definition. So you don't actually duplicate it here. What's not recommended? Recommendations, of course, are not fixed rules. They're just recommendations, but it's not recommended just to import one of the constants, which I don't know. I think it's not that criminal to import to do this here. Or it's I don't think it's that controversial just to import one constant if you have a mathematical procedure that uses very specific constants and you want to actually make it very visible on the top level what you're using, then I don't know. So anyway. And then accessing all the constant values is also then you can just add that like that. So say that you're going to use all of them. But it's the same syntax as this one, except that you're being a little bit more verbose. And then when we're talking about the standard prelude, it means that the Rust system by default does certain external references, and for example, it refers to the standard, the std crate by default. So it's not something you put in your own code. So that in Rust you're working on a little bit higher level of abstraction, so that's always a little. And then it also imports a whole bunch of stuff from this structure here, to give you a certain minimum viable set of functionality. And then prelude is kind of used as a keyword also. So in many modules, or in some modules, you will see this prelude uses, and that's basically an indicator that you should import everything under that section. And I'll have a look at the item definition in Rust, or what are items in Rust. And some of these we've covered earlier also in previous episodes, so I won't be redoing the whole description of them. So functions is one artifact, and we've gone through quite many of those use cases already. Built-in types, we've covered them in an earlier episode also. And then you have specific user-defined types. So you have struct, enum, and trait. So here we see a simple struct definition, and then an enumerator is an enumerator definition, and then we have a trait definition here. And then, in addition to those item handling, then you can have type aliases. So you can say type unsigned integer 8 is referring to the base type U8. And then here we see it used. You can use the impossibly long name in replacement of the U8. To be really clear what you mean. Then we have implementation blocks, where you have, we define it just a standard struct, so ignore the rest of the code, and then you take that and then you implement drawable for the circle, and then drawable requires that you implement a couple of functions for that. And then we have the definition of constants. So public constant, top temperature, a specific type. And then we have the definition of static, which is a value that exists for the whole runtime of the program, but can be a mutable type also. And we covered this in an earlier episode. And just to give a hint that it's a little bit more complicated than just this level of a demo. So, but we I actually covered that early. Yeah, and then here's the example of why you should go and watch my previous video. When you try and do that, then you'll get an error, and you'll understand why you need to watch the previous video. And then modules, but we've already gone through that. Imports. Give an example where you can find a use case for that. Should we have a look at it more? Calculate separate, but I didn't think I showed that. What's that one? Yeah, exactly. You basically, when you're importing stuff, then you use use statements. So the concept in Rust is to use use. You don't use the keyword import. And then extern block is a functionality where you can basically say that you can refer to non-Rust code directly in your code, so you can refer to blocks that are, you know, generated in C++ or C or whatever. And then we have a library definition. So let's see now. Here I created a library definition here. And the key here is that you have a lib file instead of a mod file. And then you actually export the or import the functionality around it. So we have two modules here. Is this one with the add, and then this one with subtract. And then due to the fact that that has the lib in the lib definition file, then Rust will automatically compile it. This as a library, or it will compile the calculate separate lib as a library. And then when you're accessing it, then I've used the long form. Or of course, you can use a use statement to actually make this shorter. But I just wanted to make it clear how you access it. So basically, when you move to a library, then it's a little bit more restrictive on how you can access things in the library. So you have to make it more explicit. What are you providing to the external world, and then using module. So the source bin directory. Actually, this one I made a separate example, because there's a method where if you're making very simple programs, that then you can actually have in the source directory, you can have a module definitions, and then you can have a bin directory which only contains main, the code for main, and then you can compile that as a application. So if you're interested in that, then it's basically it's a simplified version of this example, and I put it into this one here, into a separate package. And then of course a library can be put in its own project. We have also covered that in a previous episode. But I wanted to list here also in this presentation, I wanted to list those items to actually, so that if you're new to the series, then you don't think that it hasn't been. Why didn't you mention X, Y, Z? Many will ask if they haven't watched my previous episode. Haven't you covered that, this, that, and the others? Okay, moving along. And then we come to attributes, and attributes is basically you can override default behavior of Rust. And I've tried to include some more of them, the more used or more relevant examples. And there are lots of options, so if you really want to dig into every single option and the usage of it in detail, then I suggest you dig up the documentation. So this is allow. Well, it's pretty easy to syntax. So you start with a hash and then the brackets, and then it's usually a allow or deny or error or warning. So in this case, you can say that I've defined a variable, and since it hasn't got an underscore and it's not used, then I'll get a warning. But then you can actually say that, okay, don't in this specific case for this variable, don't care that it's not used. And then non-snake case means that don't give me a hard time for not having the Rust recommended formatting name style for the variable. And it'll make it explicit then, like for what specific items do you want this exception to be taken. You could also do these overrides globally, but I don't know, I wouldn't recommend it personally. And then you can define sections that are only going to be used for certain platforms. So, for example, config Windows, and then again, allow unused variables. And then that means that they use this for Windows. Use this only when compiling on Windows, or for Windows for the Windows. No, when you are targeting the Windows platform. Inline. Inline is that it will try and put the code directly in that location. It's for optimization purposes often. And but this is taken by the compiler as a suggestion if you don't specifically say inline always. And as compilers go, I would say that compilers will still probably take issue with certain types of inline requests and not do it. So you can either say inline, which is a suggestion. You can say inline always, which will theoretically force the compiler to always do it, or never to inline, which I think the compiler will probably respect. And then you have a let's see. Oh yeah. The test attribute, which defines that, and this we've seen in earlier examples. So you define what code is defined as a test, and then you can actually use more global, like more sort of wildcard selection of. So like apply the attribute to all valid targets. And then this one's interesting here, enable experimental features. So if you know what experimental features there are in Rust, then you can actually say, okay, at this specific location, enable a specific type of experimental feature. This is not a no. I don't know if this is even exists as an experiment. I just added it as an example. But there's probably somewhere on the developer page or something you can actually pick up a whole bunch of these experimental stuff. And then we get to an interesting section, which is test and documentation. And in this case, we need to cover this in a little bit more detail, and that will be coming in this same episode. Because we left out some details. And then there's an attribute should panic for a test. So you set up a test that actually should, you know that it's going to panic. So then you actually tell the system that, you expect it to panic, and it will create a divide by 0 so that it will not actually panic the code and stop the test, stop everything. And then this is the tricky observation or reality. So tests, maybe not many realize this, but all the tests that you define are executed multi-threaded by default. So you can have tests running in parallel. And if you don't know this, you might actually be writing test code that has subtle interdependencies, like accessing the same file or writing to the same file, because you don't realize that they're multi-threaded, executed multi-threaded. And that could cause lots of very weird problems. But anyway, there is a way that you can override this so that you can actually set the environmental variable to say Rust test threads as well, and then it'll be on single thread. But I just thought I'd mention it because it's not super obvious. And then we have different categories of tests, but there's an integration test, and then I want to make I have a test directory here as an example, and you can see that this is a tests in a separate file that explicitly tests the API of the separate library. So this is useful. So you create a separate library, and then you want to have a separate piece of logic that is responsible for the API testing. Can be useful. So next we'll look into documentation generation, and the way Rust has a built-in mechanism to create HTML documentation for your project, and you can use this command cargo. And then no deps means that you only create documentation for the current project, and then open means that you open in the browser when done. And the documentation HTML source is created under target doc. And then the start page is in a subdirectory with index called index.html. When you have multiple projects, then sometimes it actually, even if you apply this open here, it won't open the documentation, because I think it gets a bit confused as to what index file to use. So you might need to search this doc structure for all the index.html and decide yourself which file you want to open. And also I've added it to one of the commands too, so you can actually use this create modules doc command. There, this one. So you can run it from the command line. Now what you can do is you can actually run the document generation without any annotations, and then it will just, make a general documentation, with some it'll show the structure and everything, so it's good enough as a general overview. But if you want to put some of your own documentation content into your project, so what you can do is you can add documentation sections to public items in your project, or any public feature as such. And we'll have a look at the examples after I've gone through all the markup. So basically, if you're going to declare a line that's going to end up in the documentation, then you use 3 slashes, and this is just the extra character to not to disable it trying to take this line from this location. So then there's there's 2, so you can give 3 slashes, and then you just write text, and then when it runs the document generation, then it will pick up that line. As I said, the line needs to be associated with a public feature. If you put it randomly wherever, then it will actually complain. Or you can actually use this here, the doc directed, and do it in that format. And actually that's strictly speaking not needed. So that's actually should be standalone on its own line. I'll have a look here. And then if you use the attention character, then you will be attaching the comment to the enclosing feature. So if you want to have a comment that's related to a module, then you put this on the first line, and then you put the attention mark, and then it will associate it with the entity of the enclosing entity and stuff. And then we can use some markups. So you can add formatting. So if you use this star, and then this will be italics, and then or that underscore, and then in italics. And then if you want to put on activate bold, then it's just 2 stars. And then there's the interesting thing, you can basically use any HTML markup, valid markup. It actually does parse. When I test it, it complains if you use the incorrect HTML markup. at least up to a certain level. Basically, I haven't tried to add JavaScript, but I would assume that it should just pass through. I would assume. But here you see that I marked this text out, so that's bold start, bold end. And then it's any other feature that is existing in HTML. Now this here is actually very important to know, and also came as a bit of a surprise to me. So if you actually have a section, a block in your comment documentation markup that is designated as code, the default behavior is that it will take all those sections and it will post them to be tests. And then when you run the test execution, then it will actually compile those and run them try to run them as tests. And I made an example here. Let's say separate. Fix that spelling mistake. I was in the separate library and add functions. So here I did the real world example of this. So these three dots here designate the start and end of a code block, and also this is a code block because it has 1, 2, 3, 4 spaces in the beginning. So it will be extracting these two sections into the to be tests. Let's see. So here we have a block of code in the doc comments. So that was the example, the two examples I showed. Then you can also you can comment out lines of code in your code lines, so that they don't get executed. And then those, and then you can add a markup saying no run. So basically, it interprets this that you have a code section, but it's not Rust code, and it will not try and interpret it. It will just pass it through. And also another tricky feature is that if you define a block of code with fn main, so it identifies that there's the string fn main, then it'll try and turn it into a separate project with its own cargo file, and then it will run it as its own independent program. Full program. I don't know if there's any other document programming, any programming environment that has this kind of that you can embed executable code in the document sections. Now let me know if there is, because this is the first occurrence of this that I've found. So here's the generated documentation open in the browser. Here we have a whole bunch of menu items. And then you can click around. It's got a certain navigation feature. And you'll also see the code blocks as generated. And then there was... Go here, and then you see here it's generated this comment. And go into main, and then here you see the main, more comments or document entries. So it's not that difficult, but it takes a bit. When I was experimenting, it takes a bit of a while to adapt to what you write up in markups and the positioning of the document lines and the style of that, and then how does it end up in here. So I found that one needed to work a little bit on that to actually try to understand a little bit better how this layout works. But I think it's good enough. So if you look at the code and then you look at this document, then you'll quite quickly understand where the different text lines will end up when you write it in the code, and then how it ends up in here. So let's run the tests and see what happens. And then we see here we see the test from add functions. Yeah, so that's where it starts. Doc tests, and then it tells you what it's running, and then running one test, and that's okay. So you see, this is where it goes and takes the code, and then it actually runs it in the test. Okay, I found an interesting deviation that I actually missed when I was testing this. Now I've defined two code blocks in this documentation for this function add, and it kind of recognizes the both, but this one is not formatted and highlighted, but this one is. And so after doing some searching and research, you see now it's working at least on this level, and we see it's working here too. And I think I'm into so many different sources, but the official sources say there should be 4 spaces prior to the code. So from here, 1, 2, 3, 4. So that's the column where the code should start. And it turns out that if you look at support forums and stuff, then it's actually 6. I mean, I don't know if this is as close as I can come to the solution, at least. So it needs to be 6 white spaces to identify a code block like it is now. And then we see that when we go down to the doc tests, and we see now it's running both of the tests as it should. So it found the top block and the bottom block. Yeah, that's programming for you. So, back to specifying dependencies in the cargo toml file, and we've done this, of course, over many of the episodes. So we've done the default. Then we've left out some details, or not used certain details. So, for example, you can get the dependency directly from a GitHub repository. So you can say, you can get, for example, in this case, we get the image implementation directly from GitHub, defining a specific revision we want to get. And then the tags you can use is revision, tag, or branch to get it from GitHub. So then it gets the raw implementation from GitHub. You can also say, and this syntax we've used for local projects, where you can actually say that, okay, there is a crate that should be accessed locally, or picked up locally from a specific directory location. I mean, it can be any kind of a directory. It can be an explicit directory location or a relative location. Now, the only thing that I haven't diagnosed that can you use environmental variables to direct this. Yeah, I'm not sure that I missed to check before this video, because I was going to look online if it were possible to put capturing environmental variables in the cargo .toml, and I think it is actually. Moving on. And when it comes to handling versions, and this I mentioned previously, basically you can give this kind of image to 0.6.1, and then that's kind of, initially that's taken by the Rust environment, package management environment, as a suggestion for a version you want to have. And then it actually does refer to what guidelines they follow, and it's this one here. And if you go to this website, then there's a very long description of how versioning should be, version selection should be handled. So then it implements that kind of logic to actually pick up the final version. And then also you can do different overrides. You can say it has to be specifically that version. So then you move the suggestion to a specific requirement. Or you need to say that it's larger or equal to this version, or within a version range, or smaller and equal to a version, or it can be basically any 0.6 version. And more information here. And I just wanted to mention that when you compile stuff, then it creates a cargo log file. And this contains information on specific dependency versions being used. So when it interprets your requirement, then in the log file it'll put the specific version that is used. And then I just wanted to mention that you can dependency version only be updated on cargo clean, and then you run the build after that, or when you do a cargo update. So there is a risk that when you're just working, you're compiling and testing and stuff, that you're not updating your crate references, and this could lead to some issues. So and then it's sometimes for that reason it's sometimes useful to actually use a text editor and go into cargo lock actually here, and then you see it's textual, so you can investigate the like, let's see if we find here, this is the specific image, and then you can actually see what version is it actually using, and then and then what dependencies does it have. So it's not really supposed to be used on a daily basis, but I find it useful for diagnosing mysterious dependency problems. And then finally we have the issue that now we've gone through the process of developing. You've set up your modules, your libraries, your dependencies and everything, and now you want to, so then you need to publish it, or you can publish it if you want. So basically the first thing you need to do is to clean out any hard-coded local references that you have in your project. So you need to put these directory references that need to be all replaced with either a dynamic situation where it's picking up it's using the directory location, but optionally it can use a specific online version of that crate, or replace it with the direct saying that's based on a specific version of a module. The cargo package is the command you use to package it up. And I'll also added it here, so you have a command for that. And then it will probably give you manifest warnings, like warning you that there's certain information missing, like has no the manifest has no description wise or whatever. So I think it's recommended you update. I think maybe some of these attributes are mandatory before you can actually upload. And the first step is you need to have an account on crates.io. And then you need to log in using a key. This key will be generated in your user preferences when you actually create an account on crates.io. And then you just use cargo publish to publish it. Let me see the project you can use. Yeah, exactly. I didn't of course I didn't put my key in there, so create modules publish. There. So then I just made it a placeholder for the key, so when you actually register, then you can go and put the key in there. But I don't suggest you upload this project because it's not. It's just for educational purpose. And then you can also last final details is that you can actually, like you can with Microsoft Code, which has its own workspace concept, you can actually create a workspace of different crates that you have. So you can create I haven't done it for this project, but you can have a root, and then you can create like 3 subdirectories, 3 different crates, and then you can create on this top level in the root, you can create a workspace definition where you say that okay, this contains these 3. If you do something, what do I meant to say? A through more. Yeah, this was just bonus items. Well, now I understand what I was running. Yeah, there's a few bonus items. So if you publish to, and you have a project and you generated the documentation for it, then when you publish it, then it will actually automatically send your documentation to docs.rs, which is kind of neat. And then there is an option to configure travisci.org. Going onto this website, you can set up automatically on published testing. And then there's also a mechanism to automate the generation of readme.md, and it's described here in this website. So I won't go into those in details. It's easy. It's more of it just to go to the website and read how to set it up, and then you're up and running. So at the end, I just thought I'd throw in the working examples of the document markup, so you can actually see what it looks like in real code. So here on top of main that I've set up here, we have the public definition of a function, and then as you see here, that is a document line. Or you can use this this style also, where you just say that it's a option, and then that's the normal comment will not be included, not included in the documentation. And then here I included the formatting ones where it's using the italics and the bold, and then the HTML markup. And then here's an example of including that that you attach a document line to a container. In this case, it will be main, but this can apply to. And then it was that I had it here, which we already looked at. So here we have code blocks, and then the 3 slashes is the documentation. I want to stop there for a while because I was thinking, did I put more examples of this? Because that can be actually attached to a module or a library definition file also, so you can get documentation written for those. See me now, I only had this example. So that was a heavy bit of information to go through, but I hope you found it useful, and it, as I said, plugs in gaps also from previous presentations where I actually did not want to go into the details of everything in question. So, and I mean, I'll do the same with as I did in the previous video. So this code will be uploaded to my GitHub site with a comment, so where to find it. So you can. The idea is that you can like download it, and then you can use this as like a copy as a basis for a project, or just a copy paste repository, so that then you can easily ramp up your own. You can build your own project on top of this infrastructure. Yeah. See you in the next one.